Hi, welcome back. Today we are going to take a look at this avionics electronic box. This thing is a triplex transducer unit. It was used in a Tornado. This thing was manufactured by GEC Avionics Limited. It is actually a triple air data computer. So we have three pairs of pitot-static input pressures here. Here we have a configuration connector. On the rear there are two connectors. So this kind of plastic is conductive, approximately 10 kilo ohms. There is here an hours counter. So this one indicates 812 hours. So this thing is quite heavy, approximately 5 kilos. So first let's open this thing to see what is inside. And after I will try to get it to work. I think it can be interesting to see how this thing works. So this thing was designed, I think, in the 70s or maybe early 80s. We should find only analog circuits inside. Okay, so we can see here several electronic boards. And here we can see two power supply units. They are identical, they have the same part number. Okay, so let's see on the other side. We have pitot and static pressure transducers. This is a dual pressure sensor from Penny and Childs. Okay, so we can see that we have 6 connections, and we can see that we have these two terminals are connected together, and also this one. So we can expect a power supply here of the two potentiometers, and the one output corresponds to this pin here, and another one here. Okay, look at that, very nice. Okay, so we can see here the potentiometer, the track of the potentiometer, and the wiper attached to this tube here. Okay, we can see the connection of the wiper. Okay, and we have a lever here. You can see this lever, which is linked mechanically to a capsule. The linkage is here. You can see the capsule, and we have a linkage here. Now we can see several resistors here. Maybe they are used for calibration. Okay, so we can see that this pressure corresponds to the internal pressure, so this is the static pressure. And we have here the second pressure input, which is the pitot pressure actually. We should find an identical thing underneath this one for the static pressure. So the capsule of the static pressure transducer is evacuated. So for the pitot transducer, the pressure inside the capsule corresponds to the pitot pressure, and for the static pressure, the capsule is evacuated. So we should find another identical assembly inside here, but I don't know, it's maybe we should, okay, it is screwed. So we have exactly the same thing. Okay, so we have a better view on the potentiometer. Okay, and we have here actually the two capsules back to back. So we can see that one is evacuated. It is the top capsule here, so this sensor corresponds to the static pressure, and you can see here that this tube corresponds to the pitot pressure. Okay, the pitot pressure here goes to the second capsule. Okay, so the capsule is sensitive to the difference of the internal pressure, which is the pitot pressure, and the inside pressure corresponding to the static pressure. For this transducer, the capsule is evacuated, and the capsule is only sensitive to the static pressure. So this is used for the altitude. It's a very nice mechanical thing. The potentiometer is very small. Okay, so we can see the wiper. We can see the brush contacts for the wiper. So we have actually 5 contacts, or 6. 5 or 6 very tiny contacts. It's a very nice sensor assembly. The second board is this one. Okay, so there are several op amps. We have mainly LM747, the dual op amps. Okay, so we can see also this very nice capacitor. So this part is an LM101. We can see that there is a red dot. So sometimes a red dot indicates that this part was tested and selected. Okay, actually there are two dots. I cannot read the reference, it is a little bit obscure. This board permits to convert the DC voltage, which comes from the potentiometer of the transducer, into a rectangular signal. The duty cycle is proportional to the pressure, either the static pressure or the dynamic pressure. Or there are two boards like that with three outputs for each pressure, and there is a smaller one here which has only two outputs, one output for the static pressure and a second output for the dynamic pressure. So we can see here a triangle generator. It uses this capacitor, which is probably a Mica capacitor. So this is this red capacitor here. So this is an integrator, and we can see that there is a feedback here. So there is a comparator and an hysteresis, which is created by this resistor. So therefore, at the output here, there is a triangle signal. We have here the rest of the circuit. This is the potentiometer of the transducer. This one is linked to the static pressure. Okay, the wiper here is connected to this voltage follower. Okay, so this is a triangle signal which is summed with a coefficient here to this voltage, which is an image of the static pressure, and the sum of these two voltages is compared to a constant voltage here. Okay, and this voltage can be adjusted a little bit using this resistor which is selected. The output here is actually the emitter of the output of the bipolar transistor. Is connected to three optocouplers. On the other side of the optocouplers here, we have the same circuit here, which permits to have rectangular signal, which is galvanically isolated from the sensor circuits here. And we have exactly the same circuit for the dynamic pressure here. We can see that we have three outputs for the dynamic pressure and three outputs also for the static pressure. Okay, you can see on the screen the schematic of that board. So there are 6 identical boards. So I called this board MAC board. This board permits to have an image of the MAC number. Okay, so let's see how this thing works. It is interesting. So we have here the two pulse width modulation signals, one corresponding to the static pressure. The second one is an image of the dynamic pressure. So we can see here 3 analog switches. So this is the 4016. One switch, this one is used as an inverter, and there are also 2 other switches here which permit to connect this signal here either to the ground, either to this voltage here. Okay, so after filtering, we have here a DC voltage, which is actually the product of the duty cycle here, that is to say the static pressure and this voltage here. So this is actually a multiplier. We have more or less the same thing for the dynamic pressure, except that we have here a reference voltage instead of a variable voltage like for the static pressure. Okay, so we can see here an integrator. Okay, so the input current here is the sum of these two currents. We can see that the output of this integrator is connected to this point here. Okay, so therefore we can say that this voltage is actually a coefficient multiplied by the static pressure and multiplied also by the output voltage here. Okay, so of course, because we have a negative feedback, this voltage is 0. Okay, and the DC current flowing through this capacitor is also null. We can see that the output here, which is an image of the dynamic pressure, is connected to this inverting amplifier. There is a small offset here. I assume that this offset permits to compensate something for the dynamic pressure. I assume that this voltage is proportional to the dynamic pressure. So let's say that this voltage is minus K2 multiplied by dynamic pressure. Okay, so this is the current actually flowing here. And because we have here negative feedback, the sum of these two currents is null. As a result, we can say that the output voltage is actually proportional to the ratio dynamic pressure over static pressure. This parameter is important for the calculation of the Mach number. If you want to compute the Mach number, you need to calculate this ratio. Okay, so from this ratio, you have another function which permits to get access to the Mach number. On that device, the Mach number is not computed actually. So here we have another analog board. Okay, so we have here other LM747. It is also the case on the right side here. We have something symmetrical, so we have two identical circuits here. Okay, so we can see here an image of one ratio. So I call the Mach number, but actually it is not directly the Mach number, but something which can be interpreted like Mach number. Okay, so we can see that we have here one image of the ratio of one board and here a ratio of the second board. So we can see this circuit is interesting. We have as this output the maximum of these two voltages. Okay, so this voltage is fed to this voltage follower. This signal is connected to another board. Okay, so this circuit permits to have the maximum Mach number of two different sensors. Okay, so this output is connected to board 0144. So this board is complicated. There are a lot of baudges here, so I didn't do the reverse engineering of that board, but because of the relays here, okay, so we can see that we have plenty of relays. I think that this signal here is fed to different comparators, which permits to activate different relays. So I think that we have discrete outputs here corresponding to different Mach numbers. Okay, so therefore this device is not exactly an air data computer. It permits to have only the static pressure, the dynamic pressure, and some discrete values of Mach numbers. Normally, an air data computer gives the altitude, vertical speed, Mach number, temperature, true airspeed, and other parameters, but here we have something different. Okay, and here we have one power supply assembly. So it's a very nice construction. It seems complicated to remove this board here. Okay, so anyway, the power supply input is here. Okay, you can see here several pass-through capacitors. Okay, so this is the TVS diode 1N5656. So this is maybe a protective diode, which is maybe in series with the power supply input here. And we have two tantalum capacitors here, castanet type, and several inductors. There is one relay. So here we have an LM111, this is the comparator. I cannot read this one. This is a transistor, okay, a joint terminal JAN. To N4854. We have here a 555. There is here a voltage reference diode 1N825, 6.4 volts, I think. And we have two other Zener diodes here. All parts have military specifications. So these things are actually inductors. Okay, on the other side, we have also other transistors and power transistors also in TO3.